Welcome back to another video. In this video, we will discuss a few things, a few challenges about uh, lead, uh, light double perovskite materials and their solutions. So, as we all know that these materials have potential to be utilized in PV industry, hydrogen storage, and catalysis. So, as we know their potential, we should also know their limitations that are hindering their commercialization in case of uh, perovskite solar cells and few others. So let's start. First of all, efficiency gap. As we know that the greater efficiency that was shown in recent studies, it was shown by this material, but it has few problems as it contain lead. If What is problem with lead? The lead is highly toxic material and we can't use it as it when it exposed to air it can cause several environmental and health issues, so we just have to remove this one. So for this, researcher and engineers put maximum effort to remove this and to get a material that is less toxic and so that our environmental concern can be removed. So uh, for this, if you are removing lead, you have to put any other material that follows strict criteria and that have band gap equal to this material. But as we are exploring different materials, different elements, like we are exploring silver, bismuth, and SN, but they have few problems. When we utilize those lead-free elements in this structure, our efficiency comes lower. So our efficiencies declines. So that is the problem. Actually, uh, it the efficiency gap comes from few reasons, in which it include wider band gap. When the band gap is wider, uh, the photon comes and did not absorb in that material, but it goes without creating or without producing any electron and hole pair. So, in case of if we will talk about solar cells, you should have uh, uh, a lower band gap, but not lower, but you have uh, in optimal, we can say that in optimum level. So when the it should be in such a way that it can absorb the photon that is coming from sun. So they have wider band gap, and this wider band gap comes from, as I discussed earlier, that when we remove that PB and introduce some other elements, it will cause a wider band gap and low carrier mobility and defects when we introduce these elements instead of lead. So there are few chances that uh, uh, the defects can be introduced. Pinholes. What these pinholes actually do, they create, like you can say that, some something they trap, uh, and they trap the electron and holes. When these electron and holes are trapped, they recombines. When they recombines, they cannot generate current, or they cannot contribute to JSC, that is short circuit current density. What is solution? The solution is doping. We can dope at B side cations. Uh, you know the structure of perovskite. It has some main major cation, that is larger cation, that is present at center, and there are few cations B and B prime. Sometime one is monovalent and other is trivalent. They are long side. So at B side or B prime side, you can uh, make doping, and by doping you can reduce the band gap. There are few studies, there are few findings that have reduced their band gap, uh, direct band gap, due to this doping. You can, for defects, you can improve the its its periodicity, so that the defects are lowered. And advanced fabrication techniques can also improve the mobility. Next, next it's material stability. So what is material stability? When you fabricate any material and you put it in your environment in normal conditions, and after that you check the material and the material was same as you put it in initial condition and final condition, there is no change in material, so that material is stable. But if the material cause some pinholes, or there is some defects that are introduced due to exposure of air or due to exposure of uh, sunlight, so this material is has instability issues. So these materials are not highly stable uh, when we uh, put it in put these material in normal conditions and environmental conditions. They degrade, as you can see that here when it was exposed to air, it caused degradation. So this degradation, in case of solar cell, these degradation increase series resistance, which is a parasitic uh, element or parasitic factor that contribute to decline in efficiency of solar cells. So they can also cause uh, defects, or they can uh, trap more uh, charge carriers, and they will cause them to recombine, and due to which your power conversion efficiency can be decreased. So we can solve these problems by uh, few things, just like these mentioned encapsulation techniques. Yani, what you can do the material. You have material and you can uh, cover it by few other layers, so that its exposure is lower to environmental condition, and it is not reduced. It means you can add some protection layer upon your main material. So you can solve this stability issue by covering it with another appropriate layer. So then toxicity few alternatives. So actually it is just you can say that you are removing lead, and you put another material like SN or BI, and your aim was to reduce the toxicity. But when you introduce SN and BI, the toxicity remain same. It means the alternative that we used did not do, or did not reduce, or did not solve that issue which we were aiming for. So we have to produce materials that are less toxic. So SN and BI are actually toxic, and SN is the material that can be oxidized so easily. So it can be exposed to air, and it will reduce and cause toxicity. So um, or we have to reduce its toxicity. You can do by doping, and fluorine doping is also a method. SN, for SN you can dope with fluorine, so that it does not oxidize. Actually, it oxidizes due to its higher in a one orbit, its d orbit is energized, so that's why it oxidize. So uh, what are the solutions? We can use truly non-toxic elements instead of that, as like silver, and we should prefer abundant element. If you are replacing any material, you should know that uh, the one thing that you have to put in mind, it's its abundance. As you know that if you are putting any material that is a rare material, it will cause a higher cost. So that your technology or your new this uh, new PV cells will be expensive, but we have to make less expensive and highly efficient solar cells. So you can use copper or silver. Thank you very much. If you have any question, you can contact me on osama1520 and I will try to solve if I can. Uh, you can read by yourself, and if you have any problem, you can ask. Thank you very much.